Hey,
Hello.
welcome to FPV Pytaniashka channel. Today with us, Chief Technology Officer at Neros, Olaf Hichwa. Olaf, the CTO of Neros, an engineer who went from building his own PCBs in school to leading the biggest FPV drone manufacturer in America, producing thousands of drones in America per month. Neros, the startup company Olaf has established, aims to build China-free drones for defense tech and build them in the United States rather than in China from US-based components, which is very important. It may sound like reindustrialization of America, but in reality, it is a very ambitious plan. Thanks for joining, Olaf.
Awesome. Thank you so much for the kind introduction. And that was a great summary of what we're trying to do. I think it's a really critical problem that China can make a drone a second, no problem via DJI. They make tens of millions of drones per year right now, whereas the American industrial base is only capable of producing tens of thousands, maybe low hundreds of thousands. We have an asymmetry that is unbelievable between the West, really, and China or the East. And I think that Ukraine is doing incredible progress. Like that's where the vast majority of drone innovation goes. That's where the best drones in the world are. We started the company around going to Ukraine and seeing the innovation there and just seeing how incredible the technology is there. And the largest gap we identified was that, there's a lot of production happening in country, but a lot of the components being used in Ukraine are China based. And we think the way we can help the most with this, massive problem is by tackling the component level design and bringing components availability to the West.
Sounds very cool, and I really enjoyed to have this interview, to have an opportunity to ask questions and bring your knowledge and your perspective to Ukrainian FPV hobbyists, pilots, and other people. So this interview will be in Ukrainian, and also there will be English track for other audiences. And at this moment, in the very beginning, I'd like to take a moment and thank American people and you for supporting Ukraine. I'm impressed with what American people have done so far for us, and you actually continue doing. And this stamina and perseverance is very appreciated. Thank you very much. So the first question, I guess we should start from the beginning of your life. In the previous interviews, you mentioned that you've got a first racing drone for Christmas in 2014. Russian invasion in Ukraine started also in 2014. So basically, we can say that it took 10 years for you to become from a drone user to a drone constructor, and now the biggest FPV drone manufacturer in the United States. So could you tell us more about your early electronics projects? Like what stimulated you to build your own PCBs? And could you maybe describe your first PCBs, challenges, problems they had to solve, and how you started?
Yeah, that's a really great way of looking at it. I think like many people in Ukraine and working on this industry, stumbled into printed circuit boards just because they happen to be useful for a greater vision, which is like building drones that are highly performant. I was in, racing. I wasn't doing this for defense originally, but I just wanted my drones to go faster. My first drone was based on a Hobbycane KK2 flight controller, a very, very, very old flight controller. Then eventually the base flight based flight controllers came out, and I noticed my analysis was that in these early days, the flight controller had the biggest impact on the performance of the system. It also, the KK2 was very big. It drove the size of the frame. Back then, the ESCs were on the arms. So the smaller the flight controller can get, the more performant the system can get, because the smaller the frame gets and everything just goes down from there. So my goal was to design a flight controller. And I started, Googling a little bit at the time and found JLC PCD. I think as most people do. This was a little after 2014. This was in high school in 2018 or so. Before they had like pick and place offering, but JLC PCB was the PCB vendor, and Easy EDA was the tool of choice. And as a stepping stone before the flight controller design, I started working on a VTX on-off switch. So like as simple as it gets, but we wanted to do team racing. We wanted to have a bunch of drones in a mine. So there was a little MOSFET that powered the VTX, and you would send an aux command via Betaflight to the transistor, and it would turn on your VTX, and then you could switch between a bunch of drones. So you could fly a bunch, crash a drone in a race, and then switch back. And seeing that, like, of course, very, very, very simple challenge, but I think the true passion is seeing all the work go into trying to solve a problem and then seeing an actual real world outcome. And I think that's what's really, really exciting. And that's also what motivates Neros, I think, a lot to pursue the market we're in and support Ukraine as much as we can. I think we have a similar mentality of like, what's a problem we can face? And can we use like actual technological innovation? Can we deploy our engineering resources to solve something truly useful?
It sounds very very natural, and it's cool that in recent Ukrainian flight controllers we also see this capability, which you built them
Yeah.
10 years ago or so.
Component ecosystem start. And when I was first in country in 2023, of course, I'm sure I see very little of what's actually happening, but it really seemed in 2023 there was very limited component production in country. Now it's there's fully non-Chinese FPV drones coming out, and there's component ecosystems coming together, which is really incredible to see. And I think Ukraine is really leading the pathway for the West to reindustrialize by building an organic industrial base in country.
Yeah, we have to, like, otherwise it will be a hard time for us. So my next question is about the accumulation of knowledge. Like, how did you accumulate this knowledge about microelectronics and about radio frequency domain? Because radio frequency domain is like slightly more complex than just switching VTX on and off and things like that. So it's very interesting because you basically accumulated this knowledge during school or maybe high school. So it's particularly interesting to know like what kind of RF projects you did and with whom you interacted to learn, because the challenges and the solutions often come from your environment, from the people you are interacting. And it may be particularly interesting for Ukrainian teenagers who may be interested in more deep technical stuff like LoRa or maybe spread spectrum factor or frequency hopping and things like that. So the short version of my question is how and from whom did you learn?
If I had to give a one-word answer, it's youtube.com. That's their all their information double. But I think the learning needs to start from motivation. Taking a lecture in a class just to get a good grade or something like that is a very inefficient way to learn. It's possible, people do go to university and learn incredible things, but I think people who really understand technology deeply don't learn it through like lectures because they want a good grade. They learn it because they want to achieve a mission, whether that mission is turn a VTX on and off, or that mission is, a fight for freedom. It's the core there is having that like deeper reason to learn. Looking at my pathway specifically, it was FPV YouTube, like the Joshua Bardwell was probably like the starting route. Back in the like first half of the 2010s. I don't know if Bardwell was the biggest, but the like starting on higher level, like how do FPV systems work was where I started. And then I wanted to dig in a little deeper into the electronics. So I found like Phil's lab. Beyond Joshua Bartwell, I found Robert Ferenik on YouTube. He does a bunch of like PCB layout content. I found Phil's lab on YouTube, also a bunch of PCB content. And then I would just Google based on technology, like I was working on a project that needed like PCI Express routed. So, you Google PCI Express, and then Texas Instruments has a great like routing guide on PCI Express specifically. And just like slowly learning via YouTube, via Googling on structured projects, I think was the strategy I took. And that got like you can only go, well, there's only so far you can go like fully on your own, I think. And like when I was designing the flight controller, I mean, it's pretty simple. It was just a STM32F4 and an MPU 6000 IMU. That was like no problem to do on my own. But beyond like flight controller and just getting started into RF, definitely needed some mentorship. So I went out in high school and I got a job working for a defense company that was doing software defined radio design. And that defense company was run by an RF PhD. That was very, very smart, much smarter than I hope to ever be. But that like ability to get mentorship from someone that already had some of that experience, combined with the obsessive Googling and YouTubing, I think was really, really important. And if I had to pick one that's really useful, it's definitely the YouTube education. Like I think that's the larger part of the equation. But having quality mentors, people that can guide you in general directions or ask questions when you get really, really stuck, was really useful. And all of this is like, back to what I said in the beginning, not very useful unless you have like a project or a reason for motivation. Just like watching YouTube videos because they're cool, or like even if they're good content, just like passively learning doesn't really work for me. I to actually go deep, I have to have like a specific project. I want this VTX to turn on and off. I want this flight controller to work. I want this radio to work, and then dig really deep on the technological blockers to make that happen. Um, Realistically, I think that as Neros has grown, we're a significantly larger company now, and definitely like my engineering ability has quickly been outpaced by the like incredible team we have here. The real geniuses are in the engineering lab over there, but the learning opportunity there has been amazing, and I've learned so much, and I'm sure I will learn so much more on how engineering works as a system, as an organization, and learning from the people here, a lot of which are self-taught, YouTube University graduates themselves, about how engineering happens.
Yeah, this amount of information, like in case of online courses, different education videos, is a massive booster, definitely, because like when I started looking into some areas which I didn't know and was curious about, for instance, Coursera or YouTube or maybe some other courses provide a very, very good foundation to look around and find out what else, where to dig deeper. But this mentorship from a RF PhD is also kind of very, very helpful. I guess it was something that definitely improved your skills and knowledge in the RF domain. So the next question.
Realistically, he provided the project, right? Like I was working for him, and he provided the software-defined radio that we were working on. I think learning needs to have projects.
Yeah,
It's having that is really helpful.
sure. Super. Then the next question. Like, as a CTO of Neros, you know quite a lot about drones warfare in Ukraine, about how drones developed, about how drones countermeasures developed. And as a manufacturer, you know a lot about the supply chain, about the power of suppliers. And it's not a secret that most of the drones in Russian-Ukrainian war are made of Chinese components. Chinese components manufacturers and drone manufacturers ramped up their production lines, money from the war-fueled R&D. And now with new and innovative products from China, they flood the market. They get tested in this defense environment and get improved every day. For instance, in Shahed drones, there were only 4-channel CRPA antennas, and now there are 12 channels. And these are Chinese antennas, making beamforming, jamming mitigation from up to 10 sources. There were pictures from radio modem for mesh network in these Shahed drones doing MIMA and frequency hopping. So we'll definitely see more military-grade stuff invented in China. And all production lines are also in China. So how can we, by we I mean the Western civilization, how can we achieve something similar in 2-3 years? Like China-free drones, and whether we can really compete with them. Do we have a chance?
Yeah, I think that China, like, it's so obvious how much China is winning here, right? And I'm preaching to the choir, but the having, both sides innovate and provide that information back to the factory of China. They get innovation from the Russians, they get innovations from the Ukrainians, they get innovation from everyone, and then they build their production capacity. By buying Chinese components, we're subsidizing our potential enemies' production capability, their industrial base. And that's the most broken backwards thing possible. And realistically, Ukrainians need China, right? Like if China stopped producing components, we would be in a really, really, really bad position. So it's not going to happen overnight, but it would be incredible if the West had the same industrial capacity that China had, such that we can play that same card. The reason that, we go and send all of our information, our ideas, our battlefield testing to China is because JLC PCB will make you a flight controller for $1 or something like that. And why is that? Well, in China, they have limited labor regulations. It's not so much the cost of labor that's a major factor. It's the regulations around labor. There's more discipline. People work harder. I've been to China and I've seen these factories where the discipline on work is really important. It's not that like the conditions are poor or that people are like enslaved. It's more that they have like a respect for their job that's much higher. I feel like in the States and in a lot of Western countries, you kind of just like show up to work. You don't really care too much. You're looking at your clock a lot. When do I get to leave? And you're not really invested in your craft. I feel like that kind of mindset is very, very different in China. Like you go to work for a country or a company that you want to invest your precious resources into, that you want to win, and everyone is very, very eager to support the company and support the vision, and the level of quality that is expected out of each worker is much higher. And I think like it's the core cultural component that built the industrial base in China, not necessarily the cost of labor. There's lots of interesting analyses on YouTube actually about like, why can't the iPhone be made in China or outside of China? And it's not the cost of labor. The cost of labor could easily be covered in the States. It's the talented industrial base. I think it's also like regulations in China. As an example, the PCB industry is extremely prolific and supported by the government. They understand that, electronics have a huge impact on their future national sovereignty. Being the electronics capital of the world is so critical to China's defense strategy, and the government is willing to support that. The government is willing to streamline processes for approval of new SMT houses, as an example. They're willing to zone new areas very, very quickly. And that's just not the case in the States. I think that can be the case in Ukraine and maybe some, more faster moving countries. But in the United States, it's been like trying to do, SMT even is just a regulatory, it's extremely difficult from a regulatory perspective. Don't even get started on like bare board manufacturing, getting certifications to deal with the chemicals involved with, lithography or any of the other PCB processes is so hard. So I think it's really like a society level change that needs to happen where The West needs to believe in production capacity. We need to have a movement around reindustrialization where people are really, really proud of the work they do. And they're really proud to go work at a factory and build serious physical products. They're proud that their products are often used for national security. They're used for defense. They're used to, deter future conflicts. And they're really proud of what a nation can put together as in terms of industrial capacity.
Uh, yeah, it sounds really interesting, and I understand that the gap the gap is quite big.
Yeah, I mean, I think I'd be curious to get your perspective on if you think like Ukraine is going to be the kind of starting point of Western industrialization as a country that's already had the push for reindustrialization made so obvious.
Yeah, we observe it, and we see how much we need to do, and like different bits and pieces needs to be reestablished, or different capabilities needs to be developed. Let's move on to the next question. Uh, like, I know that you develop quite a lot of new electronic components for the drones, for Neros drones. And during the development, you need to make different product decisions. Like, during the last years, you witnessed the development of different, like, jamming techniques for control, for video, and then invention of these optical line drones. If we speak about the low-tech FPV drones, they have more or less standard components, standard interfaces between these components, more or less. That's why engineers in the field are often to change components to get the maximum effect. But if you plan to sell your drones to the United States Army or some other Western army that is not in the direct conflict, most likely they will ask you questions like, how do we achieve RF anti-jamming if we do not know what will be in the battlefield in 2 years or 3 years? So probably you need somehow to design it to be agile enough to be able to change something in the future. So how do you deal with this uncertainty?
I think FPV is super exciting because it is a highly modular space. If you were to take a very silly weapon system like the Switchblade 600 and tell the engineers, I want to solder on my own receiver, they would look at you like you're crazy. But, I've seen in Ukraine where they put the receiver on the arm of the drone and then you can, unsolder the receiver and solder a new frequency back on and you're ready to go. And I think that's something that's really unique to the FPV ecosystem, that obsession with modularity, and it's super important to keep that continuing. We although we have often had to make big compromises technically for it, we've tried to keep the standard FPV architecture as much as possible. Like our custom VTX, it's a US made VTX, a 5-watt VTX, uses the standard TBS smart audio. It uses the same pinout as a TBS VTX, so you can take our VTX out and put another VTX in. I think that keeping that standard FPV architecture as much as possible is critical to maintaining that flexibility, and that's how you win conflicts long term, right? You need to be faster than the enemy, more agile than the enemy, and I think that's part of the reason like weapon systems like the Switchblade have been so ineffective. When the Switchblade was first designed, maybe it was the best radio in the world, but now 10 years later or more, it just doesn't compete. So like generally the way we look at this is we try and convince the DoD as much as possible to, make sure that the radios are swappable. Since that's a part that goes obsolete very quickly. Make sure it's a single module that can be taken out. You're also probably going to want to realize that you need to have, ground stations work with many generations of drones, right? Like maybe the drones are very cheap and you swap out the drones quickly, but the ground stations should still exist. And beyond that, maybe the training of the users has to be, consistent from generation to generation. But I think like Ukraine really sets the gold standard in modularity. Everyone follows the FPV architecture, mostly that I've seen at least, and users are expected to swap things in and out at any time, which is really incredible and something that the US DoD should be pushing for more. With that being said, there are some caveats in that you can't follow the FPV standards for everything because then you won't innovate. Like as an example, we consider it very, very important to have a very large separation between the radio mast for our custom radio and the pilot. So we have a 1,000-meter compatible system that can provide a kilometer of separation. You're not going to run TBS Crossfire over or like Crossfire over UART over 1,000 kilometers. It's just never going to work. So you need to switch to something like RS-485, which we did. And in that case, that breaks a little bit of the FTD standard, right? Because then now this runs off RS-485. You can't plug this in the back of your TX16 super easily. So it's always a trade-off between aggressively prioritizing the standard FPV architectures and making some calculated decisions to increase performance significantly.
Yeah, but in the future, everything will be over IP, so you will just plug it to some to some IP-based infrastructure, and it's okay.
100%.
Yeah, let's move on to the next question. Like, let's consider it in practice. I mean, the agility and possibility to introduce some changes to your design. Like in the recent month, the tactics of Russian army has changed from motorcycles or motorbikes to the use of infantry with anti-thermal camera cloaks. So they dress these cloaks and walk at night to infiltrate through the Ukrainian positions in small groups, like one person, maybe 2, 3, 4 people in small group, walking as much as they could at night and then hiding during the day period. And these moves they happen in difficult landscape like forests or maybe ravines where you can't really work with the regular drones or with drones equipped only with the ground station. So you need either retransmitter, or you need some optical stuff, or something that will allow your work in the ravens. So how you as a CTO of Neros would plan for short-term and mid-term product decisions to implement countermeasures of this change?
Short term, it's about selecting new components and keeping things modular, swapping them out. Like with the first repeaters that came out, right? It was just, FPV VRX on 1.3, FPV TX on 5.8, just solder the CVVS wires to go together and you're all good. And that will, get you the first, you'll be first to market with that strategy, right? Like you'll stop the new Russian TTP as quickly as possible. There's a balance to strike between something like gluing a 1.3 VRX to a 5.8 VTX and calling it good enough for a repeater, and redoing a ground up architecture where you design one board for very intelligent, having very, very strong rejection between the two, and maybe having automatic frequency changing on both ends of the link, and the more polished information or more polished architectures. And generally, I think that the local companies in Ukraine directly will do a better job than I could ever dream of at that first category of the flexibility, keep it super modular, and just try new components until it works. Where Neros hopes to help and where our mission exists is in the slightly more polished versions, once we have a new like clear proven technology that's been analyzed via these like component level decisions, can we take that and refine it a little bit while still maintaining flexibility for the future? But can we refine it to provide better performance? And like we have a bunch of projects on that front of like refinement. We're working on a repeater, which I think will be really interesting. But generally, the strategy I would take is whenever there's a new like Russian strategy, solve it with likely Chinese components, or if possible, local Ukrainian made components that you're not designing yourself, that you're just, grabbing from other vendors using that, innovation ecosystem to generate those components, and then trying it out and iterating really, really quickly, getting some real results, and eventually going to the polished configuration.
Yeah, sounds very very cool. And the only comment I have on this is to try to keep the software part of it closed source so that it's not gets widespread very quickly.
What do you
Yeah.
uh, How do you think, projects like LoRa or other, like pseudo open source projects are gonna progress throughout the war, like, and after the war is won? Like, is NATO gonna have, a NATO ELRS or something like that? Or how are these like open source defense projects?
You tell me, but I guess like the uh, alliance or some countries supporting Ukraine might actually get the access to these software products, because software is quite hard to imitate, and software has to change very fast. Uh, probably you heard stories about TBS and things like that, and how it changed throughout this period. So now we
Yeah.
now we move on to the next question, like if you don't mind. Uh, so the question is about the common design pattern, which is some RF front end and some processing like MCU or some processor or some stuff. Uh, how far are we from getting specific RF radio chips developed for drones, not for some, I don't know, generic IoT stuff or some television or something else, but designed specifically for drones, or designed specifically as an object which will be used in the future wars?
RTC 6705 and RTC 6715 are not going to power FPVs forever. We're very much limited, I think, on like drone chips specifically. Um, DJI, very very interesting story that's maybe not as well understood. WTF FPV has a great article on this, but um, DJI, being strategically important to the Chinese government, essentially gained access to these two pretty substantial microelectronics chip companies in China. The companies were LeadCore and Artosin, and both of these companies worked in the like mobile phone, very low end mobile phone and image processing vertical. So they made like the image processors behind security cameras, or the like SoC, system on chip, that you would put in a like $300 phone for the Indian market, a very, very low cost smartphone. But they had experience, mixing together ARM cores and various like hardware accelerators like H265 encoders, that kind of thing, onto one chip, and then, shipping that out as a mobile phone SoC. If you think about what goes into a drone, it's a very similar architecture, right? You need some sort of vision stack. Drones always have cameras. You need some sort of RF stack, just like a phone has, a cellular stack. You need some sort of likely ARM-based compute. That's where you're going to run your flight controller on. Ideally, a real-time core and something bigger that will do your mission computing. We call it, like your terminal guidance, position hold, that kind of thing. And I think that to get like DJI level performance, it's very obvious that it needs to be a custom chip from the ground up. And it's really concerning that the West doesn't have a drone on a chip. China does, right? DJI has spent ridiculous amounts of money. I mean, likely billions of dollars developing these this like capability of a drone on a chip. And the West has resources. We're the leaders in world technology. We just haven't applied those resources towards drone on a chip. Instead, we're still making another app for food delivery or something like that, unfortunately. So I think that to achieve drone dominance for the West to reasonably like compete directly with China, we do need to have a drone on chip. And I would love to see, without getting into too many details, I would love to see Neros tackle an endeavor like that. I believe that like our value add, we have to be very understanding of what we're good at and what we're not. And I've learned the hard way for sure that the pace of innovation directly in Ukraine cannot be matched by a foreign company. Like we cannot, change frequencies faster than someone local or swap out a VTX faster. We have to like leave that to people that are closer to the action. But an area where we can contribute significantly is these like, stepwise changes in performance, in radio performance, that kind of thing. And I think that's exactly what a drone on chip would provide a custom circuit that has purpose built RF stack, very closely coupled with the autonomy stack, very closely coupled with your, imaging coding and your compression algorithm all in one die to lower cost.
Yeah, but if we speak about these components, probably there will be some interim solution, which still uses some existing chips. Like currently, a lot of drones for radio or remote control, they use LoRa chips by Semtech, which is also a US-based company making great products. So probably there will be some interim solutions based on some already available chips. And let's say in Ukraine, a lot of pilots still fly analog video, and it is still a king. So how far are we from invention of reliable and inexpensive digital links for the radio? And on what kind of radio chips it will be? Will it be on 4G, 5G, or it will be something way from a different?
Lots of people are doing the Semtech strategy. They're taking a bunch of LR1121s and like gluing them to one board and then trying to do some sort of video transmission on that architecture. I think LoRa is really, really impressive and it speaks for itself, right? Like the results on Semtech chips is like unmatched. I bet you like of the chip vendors, Semtech probably has one of the highest, if not the highest number of like battlefield successful missions, successful kills based on their technology. So I don't see LoRa going away anytime soon for command and control. I don't know if LoRa is the right way to do video, and I don't see LTE really being the right way to do video outside of more like specialized use cases. Obviously Operation Spider's Web was extremely effective, so results speak for themselves there. But I don't see every FPV getting equipped with an LTE transceiver anytime soon. I do see potential for Starlink. I think Starlink is one of the West's greatest technological innovations. And the Starlink factory is improving very, very, very rapidly. They're very serious about vertical integration. Their production line is insane. The lines of custom printed circuit board manufacturing in Texas that they have is crazy. They're one of the only companies that is doing bare board manufacturing. They're actually, doing the substrates themselves here in the States. And I think that level of innovation, that level of investment into technological progress is likely going to yield, significant improvements to the point where maybe every drone of the future will have a Starlink on it.
Yeah, it definitely looks very promising, and it's already used quite heavily around the battlefield. So
Of course.
definitely,
Question: when does every FTV have one, or will every FTV have one day? And I could definitely see that being possible.
yeah. It looks very very interesting that it's quite resilient, and with the technology and manufacturing capacity, it looks very promising. Thanks. I was mostly into the smaller chips, but you consider it's already established and big products and big projects. Yeah. So the next question, like moving to the suppliers. Like Neros is a startup company, and in the mission of making Chinese-free drones, you can't make each and every component in-house. Like, for instance, MOSFETs or processors or magnets for motors. But there may be some other critical technologies or software, for instance, that your drones rely on. So can you tell us more about your vision of the strategic partnerships around the globe and maybe in Ukraine? Like, do you need some technology partners, or do you need some technologies to provide, for instance, swarm capability or autonomy? And in which areas? Like, do you plan to acquire some partners in this? And as the continuation, like, do you plan to supply your solutions or maybe supply your technologies like radio systems to other friendly manufacturers? So it is about partnering in and partnering out.
Yeah. I ask myself, like, how come like the Chinese had the LR, 1121 based ELRS links, way like super, super fast, right? Like they came out with like the next generation chipset well ahead of many people. And that same lesson can be learned across the board. The Chinese have non-standard VTX frequencies now from 6 to 7 gigahertz as an example. The Chinese always seem to be first for this, at least from my perspective. Maybe I don't see exactly what's happening all the time, but the Chinese always seem to be like first to come out with these like new building blocks. And it just like it used to like just wonder like why are we doing so poorly? Like what's the difference? And I think if you look at like Neros specifically, Neros has somewhere in the range right now of 30 engineers working on this problem full time. Um, and in China, there's probably like 100,000 engineers. If I had to throw a dart at the wall on how many people are working on the FPV problem, and they're trying all sorts of things. And so I think that like not taking advantage of the 100,000 engineers level like community is really, really silly. So by that logic, like vertical integration, at least early on, doesn't make much sense. Obviously, we don't want to take advantage of the 100,000 people in China. We want to build an industrial base here, but that goes back to the same issue of there aren't very many people working on FPV in America. Let's say there's, ballpark 30 engineers working on it. For Neros, I would be surprised if there's more than 100 people in all of America working on FPV drones, which is pretty terrifying. So I think, we've been forced to vertically integrate because like there were no VTXs on the market outside of China. They just didn't exist. We had no choice. There were no RXs. There were no ELRS. It's just a super long list of lack of components. But in general, Neros is absolutely obsessed with building that, like 100,000 engineer level community of component vendors in the States or around the world, in Ukraine, wherever it may be, and forming these very, very tight partnerships. The reason we would want to vertically integrate is, well, one, if we can't get anything, like if it just doesn't exist on the market, we have no choice, we have to. Or two, if it really is a something that needs to be, core to our manufacturing strategy. Being vertically, doing our flight controller, in-house vertically integrated with a radio on the back is very helpful to mass manufacture the product, and having that like direct control over the architecture of that kind of thing enables mass manufacturing much more effectively. So generally the framework we use is like, does the component exist? If it doesn't exist, then let's make it ourselves. If it exists and it's cost effective, biased towards buying it externally, unless it's really critical to the manufacturability, reliability of our product, in which case we should probably make it ourselves anyway. That way we can make sure that it's, as compatible with our process as possible.
Mm-hmm. Yeah, it's quite interesting. So you are mostly focused on having everything inside the frame of the drone, and the rest is more or less can be brought in. Okay, I see. Quite cool. So we can move on to the next question. I guess it's very interesting. So we finally come to it. Like in the previous months, maybe, or a year, we observed some moves of the new United States administration to force giants like TSMC to invest more into the United States-based production capabilities. So it was there was a lot in the news about it, and it looks like TSMC confirmed that they will be doing something. And also quite recently there were news about the recent Intel bailout with a promise to do more of the contractual chip building. I'm not sure if it's if I recall it correctly, but there was bailout and promises to invest this money to the contractual chip building. So it looks like some grinding stones slowly start moving, at least in the US. Do you see some positive signs from Europe? Like you probably talk to the European parties. Like what's going on? Like do we see some positive signs from the European colleagues or governments or DOIDs?
We are slow positive signs in the States. I mean, my like key performance indicator is that it still costs 10 to 100 times more to get a piece of electronics here in the States than in China. So I'll like really see the progress once that number starts changing. Um, I think we're moving in the right direction, and it's great that there's like attention being given to this matter, to the matter of bringing industry back here. I have not seen the results that make me, think that this is a solved problem or anything like that at all close. And I also just feel like the attention is not there in Europe either. I think that we need to be pushing really hard for having like an industrial base and having the mentality of building an industrial base be core to the identity of countries. And I just personally haven't seen that a ton in Europe. With that being said, I think like recent events have started to change the tide slightly. It seems that Europe is getting very serious about drone manufacturing, and they have a lot of interesting initiatives. Like the International Drone Coalition in Europe is a great initiative towards building some of that industrial base. And you see it happening slowly with like companies like Anduril being interested in building organic production capacity in Europe. And I think that it's interesting because in Europe, there's even more necessity, right? Like the war in Ukraine is geographically closer. It's right next door, and it's like painfully obvious that if they don't have production capacity, there's going to be a lot of problems. I have not seen, in my opinion, nearly as much movement in Europe as I have in the States, and I believe that the movement in the States isn't enough to make a major impact. With that being said, I will add a caveat that the government the government loves to come to us as an example and say, where do we need more production capacity? Where can I give out development dollars or, buy stakes in companies, that kind of thing? Where can I give money to build an industrial base? And I think that's the wrong way of looking at it, because that's called like a planned economy, right? That's how the Soviet Union functioned. And the government is very bad at knowing where the industrial base needs to be. And if we went back to the States and we said, build us motors, the motor supply chain is really bad in America, then okay, maybe in 3 years they're going to give some person with a lot of lobbying ability millions of dollars to build a motor factory, but by then it'll already be too late, and who knows if the government will give it to the right person. In general, I think the government needs to be spending money on the demand of end products. right? Like there's, as an example, we can't get TVs because the, microelectronics industry to build the TV panels is not there. The US government shouldn't go say like, okay, let me fund a TV panel microelectronics company. They should just say, I'm going to buy 1 billion TVs, put a public tender up and say like, look, there's a contract here, there's clear demand, and then private industry will generate their own demand and invest in manufacturing organically. There's no need for the government to like plan out, hey, let's build this many microelectronics factories or this kind of thing. They'll, if there's a $1 billion program to buy a bunch of TVs, then private companies will be able to borrow money like from banks, given the fact that they're very likely to win this program and then stand up their own production capacity. So to summarize real quick, I think there's been an effort in the US and the mentality is really good. The effort has been too much around the government deciding what sector to fund and not enough around just like buying the end product and allowing private industry to decide in what area to fund. And I think unfortunately the US unfortunately Europe is lagging far behind the US in the urgency of this real industrialization problem. And I hope that it's changing quickly, ideally.
I recall the beginning of the full-scale invasion, uh, something like March 2022, and I'm sending some message to my friends in Europe, saying like, guys, you need to do some demonstrations or some public outcry or some other stuff to supply us weapons. And they say, weapons? No, we are against war. Like you won't get weapons from us. Say what?
That's a good way to be replaced, in my opinion, by someone that does build weapons that probably doesn't like you very much.
No, but it was like a private talk to some friends, but it was a very interesting insight about how they perceive it. Probably things changed, or at least I hope so. It looks like I'm out of the questions. Our session is very interesting and very informative, I would say. Now I would propose you an open mic so you can discuss and show and maybe tell us anything you want to tell to the audience, because I'm out of the questions.
Yeah. Well, thank you for having me. I really appreciate your time. And I think that I'm really, really excited for where things are going in terms of collaboration between the US and Ukraine specifically. I think that Ukraine has a lot of drone technology that is so far ahead of US drone technology, to be very candid. And if the general public knew how effective a $250,000 Switchblade 600 is versus a $500, Ukrainian-made FPV drone, they would be up in arms. Like that information is just not getting out enough. And I see so much importance to very, very, very tight strategic collaboration between the US and Ukraine to, US can supply very interesting technology. We can supply aid. We have a lot of value to add, and so does Ukraine. I think it's a two-way street. Ukraine really understands the importance of these low-cost systems. Unfortunately, the difference is mostly in China, in my opinion. Like Ukraine is willing to use Chinese components because it's what it's needed to survive. The US is not. But getting over that and finding ways to collaborate more, I think is really critical to the future of Western security. And Neros is extremely committed to maintaining that as much as possible. We have an office in Ukraine with multiple full-time employees. We're actually hiring aggressively there for full-time positions in Kyiv, mostly around customer service in supporting the 1,000 drones per month that we're currently sending to Ukraine, but also some deep new R&D. We're developing a lot of new technology from the ground up in Ukraine because we believe it's one of, if not the best places in the world to have these new blue sky innovations. So if anyone is interested in joining this mission, especially in Ukraine, we do have job postings open on neros.tech/careers. But yeah, I really appreciate you taking the time, and I'm a big fan of the content on YouTube.
Perfect. Thank you, Olaf. Thank you for joining and for your work, for your hard work on startup and making FPV products outshine the Chinese. Hope you succeed in it.
We
And
bring FPV back to the West. We can make FPV Western again.
we can not only fly, but also make them.
Yes.
Okay, perfect. Thanks for this interview, and hope to see you again, perhaps with some new drones and some new technologies.
We'll be back very shortly. Cheers.
Thank you.